in this question, we have two cars travel the same distance starting at 10 a.m., 11 a.m. respectively on the same day. They reach their common destination at the same point of time. First car travels for at least 6 hours. Then the highest possible value of the percentage by which the speed of the second car could exceed that of the first car is how much? Now, the bad way of solving this question, of course, would be to take variables. Distance, take it to be d. Speed of the first car, speed of the second car, different variables. Or for the time, we take time of the first car to be t, and time for the second car will be t minus 1. And then we'll get inequalities because we have at least 6 hours, which means greater than equal to 6 hours for the first car. So, of course, all of that would make things unnecessarily complicated. So this question is actually a very easy question. What matters here is not complicating it unnecessarily. You have to remember that in the CAT, they're not looking for mathematicians. It's an aptitude test. Okay, so you always have to think about a smart way of solving. So rather than any variables, rather than any inequalities, let us just directly look at the best method, which is just getting an understanding of the solution, exploring the possibilities, and seeing what kind of pattern or relationship we are getting. So if you look at the first car and the second car, let's look at the times. See, the first thing we have to understand is that they are traveling the same distance. So whatever is the ratio of their time, the reverse of that will give us ratio of the speed. Okay, so we don't really have to look at variables. We can just look at ratio of time and speed because we have the same distance. Now, what is the first possible value of the time for the first car? It's at least 6 hours, minimum 6 hours. So let's start with that. If the first car takes 6 hours, second car will take how much? See, second car is starting 1 hour after the first car, but they are still reaching at the same time. So if it's starting 1 hour later and still reaching at the same time, that means it is taking 1 hour less. Okay, so 1 hour less than 6 hours will be 5 hours. If you found that difficult, you can just think 10 a.m. and then 6 hours, that will be 4 p.m. So 11 a.m. to 4 p.m., that would be 5 hours. Now in this case, if the times are 6 and 5, okay, then ratio of time 6 is to 5, ratio of speed will be 5 is to 6. Now 5 is to 6. If I just show that, we don't even have to write. We can directly see here 5 is to 6. So percentage increase, because that's what the question is asking for. Percentage increase in the speed. From 5 to 6, we have increase in 1. 1 out of 5. 1 out of 5 will give us 20%. Basics of percentage. Similarly, if you look at the second possibility, let's look at integer values to keep it simple, just to get an idea. So we looked at minimum 6 hours. Next possibility is 7 hours, more than 6 hours. And then second car, therefore, will take 6 hours, 1 hour less. So now the ratio of the speed will be 6 is to 7. So percentage increase from 6 to 7, that will be 1 out of 6, which is 16.67%. So you can see that the percentage increase is decreasing. Okay, the value is getting smaller and we needed the highest possible value. So here itself, we can say that the answer will be 20%, 20. If you want to confirm, you can look at one last, that next after 6, 7, we'll get 8 hours. And therefore, this will be 1 hour less, 7 hours. So of course, you'll get 7 is to 8. So 1 out of 7, that will be 14.28%. Okay, even after looking at the first two percentages, that was enough. So 20%, which means answer should be option 1. Okay, so very easy question. Just for some extra practice, try out this replica question. Let us know your answer in the comment section.